Okay, this tutorial is going to help you draw a diagram that explains the formation of a V-shaped river valley. Okay, and it's actually going to be a sequence of 4 diagrams that you're going to have to draw. And as you draw each diagram, you're going to be shown the annotations that you need to make in order to explain the formation of the actual feature that we're studying. An annotation is something that's a lot more detailed than a simple label, and I'll show you how that is done in today's tutorial. Once you've drawn those sequence of diagrams, you're then going to be asked to take that and turn that into a full paragraph that describes and explains the processes that lead to the formation of a V-shaped valley. Okay, so there's actually 2 answers. Your first one is going to show you how the diagrams answer that question, and the second answer, this task here, is going to ask you just to write it without using diagrams. Okay, so let's just get started with thinking about a V-shaped river valley. Now, in this first photograph, we have a river, but it is not in a V-shaped valley yet. Okay, it is a small, narrow mountain stream that's about maybe 1 meter wide at most, and if you were to stand in it, it's no more than 20-30 centimeters in depth. Okay, at the moment it looks like it's possibly summertime, but in wintertime you have to imagine that this river would have a lot more water in it. Now what we can see is it's actually creating a little river channel. Okay, so if I was to actually kind of draw a diagram onto this, there's my land, there's my little river channel with my water in it, and there's the rest of my land. Okay, there's my little stream. Okay, and at the moment the rest of the surrounding landscape is relatively flat. Okay, although I can see that the river is definitely eating down into my landscape. So I can see that processes of erosion are occurring. Over time, give this thousands of years, this river, especially in wintertime when there's a lot more water in it, is going to erode right down. Okay, it's going to cut a deep wedge into the landscape. So anywhere where the water is in contact with the surface of the earth, it is going to be eroding it and wearing it away. So give it thousands of years, and what this looks like today will look like this. So there's my little river in the bottom of the valley, but now it's created this steep V-shaped valley. And that's the feature that we're looking to explain. How has this tiny little river that is only eating away on that one little bit of land right there actually created this very steep-sided V-shaped valley? Now there is one other feature in this apart from the V-shaped valley that we can see. There are these little hillsides that are coming down to the river on either side. We can see them there. There's a hillside coming down right there. There's another hillside coming down there. And our river is snaking in between these parts of the hills. These have actually got a name. These are called interlocking spurs. Now you may remember from National 5 geography, truncated spurs were the glacial features created by glaciers that come into V-shaped valleys and chop off the sides of the hills. So before a glacier goes into a V-shaped valley, this is what it would be looking like in this photograph, and the hillsides would go all of the way down to the actual river itself. And we call them interlocking spurs. You don't need to actually know that in your answer, but that's just one of the features you're looking at. Okay, so let's take you through each of the steps. The way you do this in geography, the way you use diagrams to explain answers, is generally done through a sequence of diagrams. So we can see here we've got 4 steps. Each diagram represents the next step in the process. Okay? And we can see that in step 1, just like in the photograph, the first photograph I showed you, our river is eroding just downwards and creating a little wedge, but give it thousands of years, and our little river has now created a V-shaped valley in the last diagram. Okay? Now these diagrams themselves don't show annotation. We have a diagram and then we have an explanation below it. What I'm going to be showing you is how to convert this into a diagram. Now, first thing you're going to need is a piece of lined paper or A4 paper, either lined or blank preferably, but it's entirely up to you. I'm going to want you to draw each of these steps onto the same A4 page. So you've got 4 diagrams. You're going to want to split your page into 4. Each diagram I'm going to be adding annotations to. Sometimes I'll actually show you the annotation, other times I will show you where the annotation would go, and it's up for you to listen to what I say and write it down in the correct place on the diagram. At the end of this, you want to take a photograph of your 4 diagrams and insert that photograph by uploading it into the Google Drive and then inserting it into your Hydrosphere virtual note set in the section that goes with the V-shaped valley diagrams. Okay, so that's the step you need to undergo once you've completed this sequence of diagrams. I would also keep your hand-drawn version safe somewhere, and then when we get back to school and print these off, these can all go neatly into your note sets. Okay, right, so I'm assuming you've got a piece of line paper and you've now drawn the outline diagram and written step 1. So this is the beginning of the process. What do we need to add? Well, first of all, you do need actually a label here. We need to label what that is. This is our river. Okay, and what our river is doing, the first annotation is our river is eroding downwards. So we would probably want to add that to this piece of this label. It's eroding down into the landscape. The other critical annotation we're going to add is that it is eroding vertically. So your annotation here, this is where you are going to write what I'm about to say in this section with an arrow pointing to the base of the river, that we have vertical erosion occurring. This is because the river is in the mountains, high above sea level, and therefore has high levels of gravitational pull, and is also probably flowing on a steep mountain slope, and therefore, due to high levels of gravity, is also eroding vertically into the landscape. Okay, so that is your detailed annotation, the one I've just described, that you would write and then point to this particular part of the diagram. And that kind of concludes step 1. We've got a detailed explanation of a process of erosion occurring, in this case vertical erosion, and we have also indicated what our diagram is actually showing with a label, and that our river is eroding downwards. Okay, underneath that on your sheet of paper, your second diagram, step 2, is just evolving that diagram. So it's taking one step forward. So take a moment to pause and just sketch this next outline diagram, and then I will show you what the annotations are. Right, first thing is our river has now eroded further into the landscape, so we want to add a small little label there. Okay, our river is now also starting to undercut the banks of the river. We can see that actually in the 2 locations there. Now it is undercutting the banks of the river through river processes like, and this is where you are now going to do something really important. You're going to tell me the two river processes that it's going to be using to undercut. The first one is hydraulic action. Once you've written that down, once you've told me that it's undercutting the riverbanks through the process of hydraulic action, you're then going to describe and explain what hydraulic action actually is. How does it work? Now, you will have done that already in this topic. You will have a description. If you look in your virtual note sets where you've watched a video and been asked to find out what hydraulic action means, and you will write that. If you can explain what hydraulic action is, you will not only get a mark for the examiner for naming hydraulic action, but you would also get a mark for explaining how it works. Okay, so let's go back to the label that we've been writing. We have the river is undercutting the riverbanks through process of erosion like hydraulic action, and you've explained what it is. The second one I would use is abrasion, which by the way is also sometimes called corrasion when it's a river, but you can just call it abrasion, makes your life easier. What you then want to do is go back in your notes and find out what abrasion means. So how does abrasion in a river work? Okay, and explain that. So be careful here though, because abrasion is also a word that you use in glaciers, and I don't want you using the glacial definition of abrasion. I want you to use the river definition. So it's the one that will have done as part of this week's lesson. So that's step 2, but we're not quite finished, because what we also have is the river banks are starting to weaken through processes of weathering. That's the label you would be adding. That the river banks are weakening through processes of weathering. Now you want to tell me one process of weathering and explain it that would be weakening these banks. That's why I've got all these little cracks. And the most obvious one to go with is freeze thaw, because you are familiar with this one. So you would write down the riverbanks are weakening through process of erosion, like freeze thaw. Now you can tell me what freeze thaw is. You can say this is where water gets into cracks in the riverbank, and then at night when temperatures drop, that water freezes and expands and weakens those cracks. Okay, and you would get a credit for explaining freeze thaw and how it works. Right, that concludes step 2. We're now going to move on to step 3. So at this stage you want to sketch your outline diagram. You can see that we have evolved the diagram further from step 2. This time I've now removed the old river banks. Now you can add these to your diagram just to indicate where the riverbank used to be, and you might even want to say this is where the riverbank used to be. So what's happened? Well, you want to say due to weathering, material starts to break off and roll down because of gravity into the river. So this is where rocks are starting to slip off down the side of the valley and end up in the river. Okay? I'm just going to show you very quickly what that would be looking like on the diagram. We can see on the valley sides lots of material breaking off and rolling into the river because of this freeze thaw process. And when it lands in the river, we can sort of see here we've got material that's landed in the river. We just add this to the diagram that we're drawing. That material then, which lands in the river, is then gradually broken down by the river itself through processes of attrition, which is where rocks collide with each other and break up. Now you could add that, not just as a label, attrition, but tell me attrition is where rocks collide with each other and break up. And then as they gradually get smaller, those little bits of rock will then be transported away downstream. Okay? Right, that concludes step 3. Let's just get to our final step. So what we now have in our final step, step 4, draw the outline diagram. Our original little river, back at the start in step 1, you can add this, was up here. You can write original river channel. And what's happened over hundreds of years is it's eroded down, but at the same time the river banks have collapsed into the river and been transported away, giving us a very deep V-shaped valley. Now everything I've just said there is something you'd want to add as a big annotation. Okay, so what you've now got is 4 steps. Around each diagram you will have added labels and annotations, and based on everything I've been telling you. So your diagram should be full of all that information. If we go back, because there is one final, by the way, you should now take a photograph of that, upload it to the Google Drive, and then insert it into your actual virtual note set in the correct place. We then just jump back. There was a second part. If you turn in your virtual note set to the next page, what you're now being asked to do is answer this question. Describe and explain. Now, all you're going to do is write out a detailed answer that takes you through the journey that I have just verbally told you, from starting with a small little river channel, cutting vertically into the landscape, explaining how that all works, moving into step 2. You don't need to say step 2 is, you just have to say then and tell me what happens, and move all of the way to the final diagram, but instead of drawing a diagram this time, you're doing it all in writing. Okay? And you're going to be marked out of 10 for your ability to describe the different steps that happen, but also to then explain how they work. Pay specific attention to the ideas of vertical erosion, hydraulic action, abrasion, freeze thaw, or freeze thaw weathering as it's sometimes called, and I also mentioned attrition. These are all processes where the river or the surrounding conditions, like water freezing at night, which leads to freeze-thaw, lead to the creation of a V-shaped valley. And if you actually look, why are these processes so important? There in the question is processes. They want to know about how these processes are involved in creating the river. So you've got two steps. You've got diagrams to draw, uploading it and putting it in to answer this part here. You've then got to write a full answer to answer this part.